Hello everybody, my name is Borisha and we are talking about Vera CPU, NVIDIA Vera CPU, and it's a part of a new series of chips from NVIDIA, and commonly it's impaired with the Rubin GPU, and we are going deeper inside the architecture of these chips as much as we can, and how much documentation allow us. So we have available documentation for the Vera CPU, NVIDIA Vera CPU, and it consists out of 88 Olympus cores, as we said previously many times before. And those cores, it is said that they are double threaded, so actually can have 176 let's say logical functions or cores. So we are talking about particularly one Olympus core and about its own architecture or architecture inside one of these 88 Olympus cores. So Olympus cores consist of out of the following architecture components. So first component named is front-end optimized branch predictors, new neural branch predictor. That's what they say in documentation with the accent on the neural. So second part of the architecture is critical path acceleration, and the third part is execution engine. So complex factor optimization. So optimizing some stuff for the advanced and advanced characteristics in things that are oriented to the AE agents and so on, and the enhance of use of AE agents. So execution engine, third part of the architecture, complex vector optimization, and four cache subsystem, latency optimize the instruction and data paths. So we are going one by one to see what is inside these architectures. So first is front end. So it says optimize the branch predictors, new neural branch predictors. So we have some unit BPU, which is named BPU here. So and it's called branch predictor unit. Of course, that's a unit for doing the predictions, and it relies itself on inside of front end on the instruction fetched unit IFU, and you see that inside of this, let's say IFU is L1 instruction cache, which is 64 kilobytes, and it's four-way. We mentioned that as we mentioned many times before, L1 cache is divided usually in these ARM architectures into instruction cache and data cache, and we see here instruction cache is inside this IFU. We will come to this part again, and then we have 128 bytes per cycle instruction fetch. So this is part of the instruction fetching, 16 instructions per cycle. So per one cycle, probably sending 16 instructions. The code queue, 48 instructions, and in that one cycle there is 10-way decode of instructions. This is just the architecture elements in a rough way shown here, and 10-way decode. So we will go through these things, every one of these things later. We just want to mention them. And then we have mid-core or critical path acceleration. So this is that part, rename allocation mid-core. We see that this 10-way decode is going down there to the mid-core, and we have elements which are combined inside which are combined inside with the various use cases. So move, elimination, memory, renaming, blah blah blah. Integer register file. So probably this is some register file like in GPUs for storing some some data or instructions. There we will see vector register file, probably for the vector operations and so on. And then we have execution engine, so obviously complex vector optimization, probably for the vector processes, and we see different units here for different operations which need to be done. Vector, probably store, load operations and stuff like that. Big store buffer, big load buffer, memory disassemble, prediction, blah blah blah. Okay, so this is section for the load and store, scheduling and execution engine. This is very interesting, and also we will see this in further videos, the purpose of this. But like it's not a very big philosophy about it, because execution engine 3 means that there is a place for execution of different kind of instructions which are decoded and need to be done in this section. And then we have a cache subsystem, latency optimized instruction, and data paths. So we see the part of this core is L2 cache, which is 2 megabytes, 8-way. We see the data ways, 32 bytes. Then we have unified STLBA, 3K entries. So it's going back to the front end. We will see the purpose of this, and then say latency optimized instruction and data paths. So this is some section to avoid latency and so on. And I'm not sure, I must check out, is real story that L2 cache is actually every core, every Olympus core have L2 cache 2 megabytes within itself, but we will check that later. Anyway, four major parts of one core, Olympus core, inside of this architecture, 1, 2, 3, and 4, and we mentioned the general purpose of them, and we will make more the description and explanation of them in the later videos. And for this time, it's okay to finish with this short introduction. Until that, I can say bye bye, just to turn myself on. Until next time.